Okay, this is the Chapter 8, video number 2, and I know there's a lot of information in this, but I will try to make this one short, or a lot of information you've had so far. Okay, so more about residuals. Right here, this is the formula that I want you to pay attention to or focus on. A linear model assumes that the relationship is a line. Residuals are part of the data, but that's what hasn't been modeled yet. Okay, the residuals are what's not on the line. Okay, so E, that's a symbol that is used for the residuals. The data, those are the Y values that you're given. And then remember, these are the predicted values. The Y hat is what's on the line, the regression line, because that's the model. Okay, so the question with the residuals is, does the model actually make sense? Okay, we're going to be looking at what's called a residual plot. Okay, when we look at the residual plot, we don't want to see anything interesting. We want it to not look like a line or a curve or anything else. That tells us that nothing interesting has been left behind, that the model is a good one. Okay, so we're going to do this. Look at the residuals plot. What we mean when we find nothing is that the scatter plot should show no relationship or association. Okay? So here's an example of what a residual plot should look like, and we're going to look at this in class on Tuesday about how you actually do this on your calculator. There should be no pattern whatsoever. This is a graph of the x values and the residuals, so that's what we're looking at. So just looking here with the residuals, do we get anything interesting? That means that the line goes through or we have the same number of residuals above it and below it, so we don't get anything interesting on here. It should look completely random. It should look like a scatter plot with no association. Another way to look at the residuals is by the standard deviation. Okay, we don't subtract x bar here. We don't subtract anything here because it would be equal to 0, because the average of the residuals is equal to 0. So the standard deviation formula is almost exactly the same. Don't worry about this 2 here. Okay, this is how we could estimate the standard deviation of the residuals. This comes up very, very occasionally. So have this in your notes. Know that it's here. But it's not something that we're going to spend a lot of time on. Okay, oh, and there it is. The mean of the residuals is equal to 0. What you should do with the residuals, though, is you should, once you have the residuals, you look at a histogram. So you would graph those residuals to show that it should look unimodal and roughly symmetric. Okay. Then we could use a regression model. We could apply this rule. Again, this comes up very, very occasionally. One thing that you will see is looking at a histogram of the residuals. But we should be able to do that, and we'll look at that in class. Okay, R squared is the next big piece of information from this. Just as you write the in context of the problem, you look at the slope and the y-intercept. We're also going to talk about something called R squared. This is the amount of variation that is accounted for by the model. Okay, the reason I left this slide as is here is the fat content in sandwiches at Burger King, doesn't really matter, and here's what the residuals are looking at. So the standard deviation is closer, these are closer together, and what we want to be able to talk about with variation is how much of the variation is accounted for by the line. Okay, that's what we're looking at. So here we can see that the residuals are closer together. I'll give you some more examples. Okay, all right, so in this example, the correlation is 0.83. It is not perfect. There are some, it doesn't make one straight perfect line. Okay, we have some variability between the residuals and between what's on the line. Okay, so we can determine how much of that is based on what's left in the residuals. And the way we do that, and there's a couple of different ways to do that, is we look at squaring the correlation. You will see it often as R squared. So this could be, a capital R squared. It gives the fraction of the data's variance that's accounted for by the model. Right here is what you want to make sure you have written in your notes. Okay, 1 minus that is the variance that's left in the residuals. right here is more often than not what you're going to have to be looking at. You will have to look at the variance, which is squaring the correlation, and then be able to talk about what does that mean as far as the line and the points that are not on the line. Okay, so here R squared is 0.83. We square that, we get 0.69. So we would say that it's 0.69 of the variance is accounted for by the model. We subtract that from 1 and we get 31% has been left in the residuals. Okay, so I have a couple more examples of this as well. Okay, so here again R squared. So this is what needs to be in your notes right here. 69% of the variation in the total fat, notice it's in context of the problem, is accounted for by the variation in the protein content. So this is your Y value. This is your X value. And if you just write in your notes pretty much a general statement, blank percent of the variation in Y is accounted for by the variation X. And then you fill in what the blanks are. You will be on the right track for being able to describe R squared. Okay, so blank percent, whatever, you would copy this, variation in whatever the Y is accounted for by variation in the X. So R squared is always going to be between 0% and 100% because you're squaring correlation, and correlation is always between 0 and 1. Okay, you do report R squared in a percent. So it doesn't really matter. It depends on what the data is. It depends on what the story that you're being told about it is, and the standard deviation is a better way to describe the residuals. But usually this is what you're talking about. What is R squared? Okay, so these are the things that you have to interpret in context of the problem. Okay, you need the slope, the y-intercept, what R means, and what R squared means. So in your notes, these are the things that we're going to be working about a lot. Okay, that was it. I told you it was going to be short.